So as we revise algebra, right? You have 5x squared plus 4 being greater than 21x. Ne? The first thing we have to do when you're looking at this problem, right? Just quickly write it down here. Plus 4 is greater than 21x. So you want to arrange it in standard form first, of which our standard form, if we can remember, it's ax squared plus bx plus c is equal to 0. That is our standard form, which means whatever has x squared should start, right? So we have 5x squared, and then followed by the one with x, the term with x, which is this one here. So because I'm taking it this side, I have to change its sign to say minus 21x, and then this side is joined by plus 4, which will be a constant, then is greater than 0. And then now that we have this, right, usually you can solve this by inspection, but other people prefer using the quadratic formula. Essentially you have to factorize this. So because there are many ways of getting the factors, I'm going to just quickly run through inspection first, right? So if you are inspecting, especially when you have like things like 5x squared, if here it's an odd number, if you have things like 3x, 5x, 7x, which are odd numbers, you simply split this to say you have 5x and x. Okay, then now this one is 4. Usually you're just going to split it to 4 and 1, but you must be strategic as to where you're going to put the 1 and where you're going to put the 4. So you do a bit of trial and error. If you put the 4 here, you're going to have 5 times 4, which is going to give you what? 20x. And then if you put the 1 here, because these are the factors of 4, so you're going to have 5. So you can have 20x, and then here you're going to have 1 times x, which is 1x. Now if I want to get negative 21, this must be negative, this must be negative to give me negative 21x. That means I should put negative here and negative. Then you would have gotten the factors. That is one way. Another way to get the factors would be to use the Paul-Shenlaw's method, right? You can check my previous videos on it, but it's essentially a factorizing technique which essentially applies if here you have only x squared. So what I would do first is that if I'm using, so I'm just gonna write alternatively. You are free to use this or stick to the quadratic formula, it's really up to you. So what you can do is that since you have 5x squared minus 21x plus 4, you need to have x squared only. So I'll divide by 5, divide by 5, divide by 5, divide by 5, so that I have x squared minus minus 21 over 5x, and then plus 4 over 5 is greater than 0. Now so you simply open two brackets, then you're gonna say x, then let me just separate these brackets a bit like this. Then you're going to say minus 21 over 5 times a half, minus u. Then you're gonna take it's simply taking this term and multiplying it by a half. Same thing is what I'm gonna do this side. So let me just quickly write that x here, and then move this bracket a bit this side, and then we should have negative 21 over 5 multiplied by a half again. Then you simply say plus u. Now the question is, how do you get your u, right? So to get u, you are simply going to say so you're simply going to multiply these two with using your calculator. So you would say that negative 21 over 5 times a half, you would multiply it by the very same thing. So I can just put it as squared. Okay, you just put it as squared. Then after that you're going to say minus u times positive u is minus u squared, then you say it's gonna be equal to 4 over 5. Okay, then after that you get an answer to this, which we're gonna get in just a minute. So we say squared minus 4 over 5 is gonna be equal to your u squared to get your u, right? It's quite a long method, isn't it? But yeah, it's because it has a coefficient. If it doesn't have a coefficient, it's gonna be quite much easier and faster. Okay, so what you then do is to put this in your calculator and find the root, right? So we're gonna find the root to get your u. So that should give you u as 19 over 10. Then now you can put that 19 over 10 here in place of u. We're gonna be putting 19 over 10, right? And then so you say 19 over 10, you say 19 over 10, then you put this in your calculator, okay? So that you're going to have x, what do you get when you put in your calculator? That should give you -4, right? And then on the other side it should give you what? It should give you x minus 1 over 5. Then you would have gotten your factors, okay? So when you fix it, right, if I can just quickly move it up a bit, right? So what will happen is that you're going to fix your factors to say, if you have a fraction, you just slide the denominator so that you have 5x minus 1. Then you would have gotten your factors, which should be the same thing as this, okay? So it's quite, it's not a complicated procedure, but it's a bit long. So you must be very careful, okay? So now that you have this, right, remember you then go to say these are your critical values, which is going to be what? 1 over 5 and 4. Then you remember you're gonna go here and then you're gonna go there, you're gonna have plus, minus, plus. Because it's not all equal to, your circles won't be shaded. And then because it says greater than 0, it means positive, so we're going to the positive side. And then you simply write this arrow as it is. So you're gonna say x is less than 1 over 5. You say or x is, you see how this arrow is, it's saying greater than 4. Then that should be your answer. Okay, so for the next question, here we go. We have the following: 2 to the power of 2x minus 6 times 2 to the power x is equal to 16. So we can go ahead and do it. 2 to the power of 2x, right? Since it says 2 to the power of 2x, you need to be careful with it. First of all, you need to write it as this, okay? Just rewriting it, but then we should have it as this, and then you can check, right, whether this is going to be one of those quadratic type of exponential equations. Okay, these are exponential equations, so you have the quadratic type. For you to maybe check, right, is that you can rewrite this as 2 to the power of x times 2 to the power x, and because x plus x is 2x, then you're gonna have this and then you have that. Okay, so usually try to do that first to see if you can get a common factor. If you do have a common factor, you can take it out, but check. I see that 2 to the power x is gonna be a common factor, and how do I take it out? I'm going to divide both sides here and here by 2 to the power x, and then multiply by 2 to the power x, which means I'll have 2 to the power x. It's gonna cancel 1, then I'm left with this, minus this goes, then I'm left with 6. But here's the problem: I'm still having 2 to the power x. So if I'm still having an exponent, a number in an exponent, then this means it's a quadratic type. Okay, it's a quadratic type. So how do we deal with it? It means we need to approach it differently. we need to express it in the form of ax squared plus bx plus c is equal to 0. And the way to do that is that you're going to write this as 2 to the power of x all to the power of 2, because this is the same as saying x times 2, which is 2x. So you're allowed to write the 2 outside, the x inside. And then you say minus 6 times 10 to the power x, and then you can say minus 16 is equal to 0, so that it looks like that form. Then now what you're going to do is that usually people use the k method, whereby they say let 2 to the power x be k. If you do that, you're gonna have k squared minus 6 times k and then minus 16. Then you can factorize, okay? And then for you to factorize that, remember you're allowed to use the quadratic formula, or you can use the method that we showed you. So using that method, what you do is that you open your bracket, you say you have k, you say minus 6 times a half, then minus u, okay? Then you say it's k minus 6 times a half plus u. Then now what you just need to do, find the u. To find the u, you multiply these two together. So you're just gonna write it as 6 times a half squared. Then you say minus u squared. It should give you the last term, which is minus 16, of which you can rewrite this as the following: plus 16 is equals to u squared. You take the root both sides, you put this in your calculator. Then your u should be, that should give you your u as 5. So therefore I will then go back and then substitute that u into that. So that means the factors would be k minus 6 times a half, then minus 5, k minus 6 times a half plus 5. Then you put that in your calculator. I think that should give you minus 8, and then when you put this in your calculator, I think that should give you 2, okay, plus 2. Then you would have factorized. Then now that you would have factorized, you can therefore say, when you continue the problem, to say therefore k will be equal to 8 or k will be equal to minus 2. But do not forget that k is 2 to the power x. So you then say 2 to the power x will be 8 or 2 to the power x will be minus 2. In this case, you write this right as 2 to the power 3, so that you then drop the base, the exponent, since the bases would be the same. We say or no solution. This one, there is no solution because there is no value of x that you can put here that will give you a negative number. So you tell them 2 to the power x is always greater than 0. You can't even get 0. There's no number that you can substitute here on x, then you get an answer as 0. There's no solution to that, okay? So that means your x should be 3. Right, I'm glad that we are getting them. So we're going to proceed now to these 1.4s and 1.3, right, which are questions that usually test your algebraic skills, okay? So this is a question that we have here: calculate a and b. You can pause the video and try it, or then we can do it. The first thing you need to do, especially if you are given, exponents such as about 2014, 2009, what, right? Those type of questions are usually quite easy. You just need to remember the following. You just need to look at the one that is smallest. This is 2014, this is 2012. 2012 is the smallest. So you need to write that 7 to the power of 2014 as 2012 plus 2, okay? 2012 plus 2, because 2012 plus 2 is 2014. Then it's all divided by 12. Then when you simplify, now why are you doing that? This is because now you can write that as 7 to the power of 2012 times 7 to the power of 2. You can be able to split them. This will be one exponent with the base 7. This will be the other exponent with the base 7. Then minus this, okay, over 12. Then when you take out a common factor there, you can take out 7 to the power of 2012 as a common factor, so that you have 7 squared minus 1 all divided by 12, right? If you struggle with taking out a common factor, this is what I usually recommend. You write this, right, minus 7 to the power 2012. You rewrite the same thing, then you say what is common. I see that 7 to the power 2012 is common, so you're going to divide by 8 both sides. Then after doing that, you're going to multiply by 8. Don't forget to multiply by 8, so that this will cancel that. You see you're left with this one. This divided by that is going to be 1, to avoid writing 0 here. So now that you would have that, right, you can simplify this to say 7 to the power of 2012. 7 squared minus 1 is what? 7 squared is 49, minus 1 is 48, okay, over 12. Now 48 over 12, 48 divided by 12, 12, 24, 36, 48, it should be 4, okay, it should be 4. So because of that, we would then have, now we can then say this is equal to 7 to the power 2012, square root of 7 to the power 2012 times square root of 4. Now you must remember that square root means, oops, so you know what I'll do. Let me just do this just to have some bit of space. So I'm gonna continue with it here, in fact here. So remember that the root sign means that you have half, okay, you have to the power of half. The square root of 4 is simply 2. Now since you have a half, this means you're gonna say 2012 divided by 2, or multiply by a half, which should give you what? Is it what? 10? It's what?
1006.
1006. Yeah, good. 1006. So you can see here that if you want to rewrite it in this form, we can rewrite it as 2 multiplied by 7 to the power of 1006. And due to this now, this means that A is 2, as you can see here, and then B is 1006. Then you would have solved the problem. So they look complicated, but actually they are easy. Okay, so for the next one, let's look at this one here. This is what we have, right? So you can give it a try. So this question, right, how we would look at it? First of all, right, they are asking us if it's possible for the graphs to intersect, and we must give a reason for the answer. Okay, so the trick here is that you understanding how graphs intersect is understanding how graphs intersect. Graphs intersect if they share the same x value and y value. Okay, so one way to one way to test whether they share the same x and y value is to say, right, for 1.4.1, since f of x is equal to 3 into x minus 1 all squared plus 5, and g of x is equal to 3. This means the y value here on g is 3. So if I put 3 here on x, on the function of f, I must get a solution, because it means this point that has 3, I don't know what is the x value, but I know that the y value is 3. So if I substitute 3 on f, I must get a certain x value, which will be the x for here, right? Because if they share the same, if they intersect, they share the same x and y value. So if we try to solve here, we're gonna have 3 minus 5 is equal to 3 into x minus 1 all squared, which is negative 2 is equal to 3 x minus 1 all squared. Then when you divide by 3, you find that x minus 1 all squared is equal to minus 2 over 3, which has no solution, because if I remember, this will always be positive because it's squared. It can't be negative. So because there is no solution, that means that there is no intersection. There is no intersection. That is the first method of solving that problem, which means the x value does not exist, which means there is no point of intersection. Another way of understanding this is the following. Since f of x is equal to 3 into x minus 1 all squared plus 5, this is a graph that has a minimum value at 5. Okay, it's a happy parabola with a minimum of 5. So you can say the minimum for f is what? Is 5. Then when you look at this, g of x is equal to 3, it's a horizontal line. You must understand that it can be written as y is equal to 3. So it's a horizontal line that is passing through here. So that means those graphs, they can never intersect. So therefore, no intersection. Okay, that is another way of looking at it. Right. Then we can go to 1.4.2. For 1.4.2, they wanted the values of k for which this has 2 unequal roots, right? So let me just paste it there. Now we're given that f of x. We're given f of x. We want to know where will this have 2, which values of k will for which this will have 2 unequal roots. Now let's understand the following. If the discriminant is equal to 0, if it's greater than 0, you're going to have real roots. If it is less than 0, you're going to have non-real roots. Okay, this is the nature of roots. Okay, but real, if the discriminant is a perfect square, if it's a perfect square, then you're going to have rational roots. Rational roots. If the discriminant is a non-perfect square, it's a non-perfect square, then you're going to have irrational roots. Irrational roots. Now, if the discriminant, so how can the discriminant have a perfect square? A perfect square is numbers such as 1, 4, 16, 9, and etc. That have a rational, or rather that have a square root. You understand me? If you put a square root, you're gonna get a certain number. So those are called perfect squares. And non-perfect will be all numbers that don't have really a square root. They do have a square root, but the square root itself is irrational. Like if you say number 2, the square root of 2 is an irrational number. So we say they are non-perfect squares. If the discriminant is equal to 0, then you're going to have equal roots. Okay, you're going to have equal roots, which means you're just going to have one solution. Okay, but if they are real, automatically it means you have unequal roots. Okay, if the discriminant is greater than 0, you have unequal roots. If the discriminant is equal to 0, you have equal roots. Equal to 0, equal to 0, equal roots. Greater than 0, unequal roots. But those unequal roots, they will either be perfect, they will either be rational roots, or they can be irrational unequal roots. Rational unequal roots or irrational unequal roots. Whether they are rational or irrational will depend on whether the discriminant is equal to a perfect square or a non-perfect square. That is what is important. So you must know that for these, they are unequal roots, because the roots are not going to be the same. Like you can have 2 and 3, negative 1 and 5. That means they are unequal. But if they are equal, you're going to have one solution. X is equal to 2, or X is equal to 2, meaning it's going to be the same number. All right. So what they want here is to say which values of k will these have 2 unequal. The moment they say unequal, it means you are talking about this. Right. So that is what we're going to solve for. But how do we solve it? Remember, f of x, you have to substitute it here to get an equation. F of x is 3 into x minus 1 all squared plus 5. G of x is 3, and then we have minus k. Then you have to put it in the standard form, which is ax squared plus bx plus c, so that we can get your discriminant. So we're going to say 3 into x squared minus 2x plus 1 plus 5 minus 3 plus k is equal to 0. This means you're going to have 3x squared minus 6x plus 3 plus 5 minus 3 plus k is equal to 0, which gives you 3x squared, and then this is minus 6x. 3 minus 3 is 0. You are left with 5 plus k. Now here, that is where you have to find your discriminant. Your discriminant, remember, it's b squared minus 4ac, which means you must identify your b, your a, and your c. This is b, right? This is a, and then the whole of this is going to be your c. Then, let me just, sorry, want to remove this part real quick. Yeah. I didn't know I could throw things around. Okay, anyway, so now you can then say since your b is -6, so your discriminant, but we need where the discriminant is greater than 0, where your b squared minus 4ac is greater than 0. So you're gonna have -6 all squared minus 4 into a, which is 3. Your c is going to be 5 plus k. Okay, so it means you're gonna have 36 minus 12 into 5 plus k. Okay, is greater than 0. And then you have 36 minus 60 minus 12k is greater than 0. When you solve this, right, it should give you minus 36. You can take it to the other side, so that is positive 36. Divide by -12, that means k, remember you divided by a negative number, so k changes the sign. 12, 24, 36, so k must be less than -3. Yeah, 36 minus that is -36, right? I'm hoping. Let's see, 36 minus 60. Oh, it's -24. So sorry. Mental math. So it's a -24. So when you take it to the other side, it becomes 24. Okay, then which means here should be 2. Okay, 12, 24. Yeah, means it should be -2. Then that would be your solution there. So for nature of roots, all the time when they're asking about real, non-real, equal, unequal, you have to find the discriminant. Then finding the discriminant, then you then check what type of roots are needed in the question. Then you're going to use the correct inequality. If they need non-real, discriminant should be less than 0. Real, discriminant should be greater than 0. Equal roots, it should be equal to 0. But this is also unequal. They are real and unequal. Here it's equal. If they say unequal and irrational, or they just say rational, you know that you have to solve for this and check whether it's a perfect square. Right, so let's look at this one before we go. This question says that simplify without the use of a calculator, right? Let's just play around with exponents and sets and see if we still remember. So here you have the root of 3 and the root of 48. So how to solve this is that you're going to say this is the root of 3 times the root. You see this 48, you're going to take your calculator, you punch in 48, you say equal sign, then you're going to press the buttons shift, then you're going to press the button fact. This fact button is on what? I think it's on this one with some coordinates of some sort, you know, those apostrophes and stuff, something like this. You should see fact. So if you do that, you're going to have 2 to the power 4 multiplied by 3, okay, minus, now here you have 4 to the power x. That one you can also do the same thing. It's going to give you 2 squared to the power x plus 1, all divided by 2 to the power 2x. Then from here, good people, I need you to know that you can then separate these things to say the root of 2 to the power 4 times the root of 3 minus 2 to the power of 2x plus 2. So what I did is that I said 2 times x, and then I said 2 times 1, which gave me this, okay, all over 2 to the power 2x. Then now the root of something times the root of something of which they are the same, it's just going to be that one inside. So another way of thinking of this is that you can say this is 3 times 3. This is the root of 3 times 3 times the root of 2 to the power 4 minus, here you can split. Now you can write it as 2 to the power 2x times 2 to the power 2 all divided by 2 to the power 2x. Then here, right, it should give you 3 squared, right? And then minus, then here you know that this one would cancel that, so you are left with 2 to the power of 2. Now good people, I need you to know that that one you can now write it as 3 squared to the power half, and then here you can write it as 2 to the power 4 to the power of half, right? Which should give you what? 2 times a half is 1, so you have 3. 4 times a half is 2, so you have 2 to the power 2 minus 2 to the power 2. Then to solve that further, you can simply take out the 2 to the power 2 as a common factor, be left with 3 minus 1. That means you have 2 to the power 2 times 2, okay, which is just 4 times 2, which is 8. Then that will be your final answer. That is it from me today, guys. I hope that you will learn something. Best of luck.